Welcome everyone. In this video we are going to prove one of my favorite mathematical tools, namely L'Hopital's rule. Now we're only going to make a proof for one of its special cases because the general proof is a lot more involved than the one that we're about to do, and I want to keep the video short. That's why we're going to do the special case. And also, before giving you the law and then proving it, I want to tell you where L'Hopital's rule is useful. For example, if you were to have a limit, let's say x approaching 0 of 1,000 divided by x, you would say that this is equal to infinity. I mean, it would depend on the side of the limit, right side and left side. So let's say, call it plus or minus infinity, to be precise. Because why is it? Well, if you divide a finite number by a big number, by a small number, I mean, you get an infinite number. You get infinity, a huge number. So this is how we would evaluate this limit. And this is fairly simple. Or if we were to have limit as x approaching infinity, perhaps, of x divided by 10, we would say that this is also infinity, basically. Because we are substituting a huge number for x, and even if we divide by 10 or 1,000, any finite number, it doesn't matter since we are substituting an incredibly huge number, we get infinity. But there are indeterminate forms. What might be an indeterminate form be? For example, if we have the limit as x approaches infinity of sine of x divided by x, and excuse me, this is not infinity, this is 0. For our case, it will make sense otherwise. So, if we have x approaching 0 and we have sine of x divided by x, well, sine of 0 is 0, and if we substitute 0 for x, we get 0 over 0. What is this? I mean, we are dividing a small number by a small number. Do we get infinity? Do we get 0? Do we get a finite number? Perhaps 1, 2, 3. What do we get? Now, in this case, we will need L'Hopital's rule to be able to evaluate this limit. Alright, so let me clear the drawings and I'm going to now introduce the rule itself. So it is L'Hopital's rule. Wow, I couldn't spell it. It is this is an I, L'Hopital's rule. And this H is capitalized. Also, there are different pronunciations of the word, different ways that it is written, but this is the way that I'm going to write in this video. I think it's a nice rule. So what does the rule tell us? Well, it tells us if we have the limit as x approaches a as some number or infinity. It can be positive infinity, plus infinity. It can be positive infinity, negative infinity. It can be 0. It can be 13. It can be pi. It can be anything and everything that you want. So we have the limit of f of x, a function, divided by g of x, another function. If this is in the form that we just solved, if this is one of our indeterminate forms, so namely, if this is 0 over 0 or if this is infinity over infinity, these are very similar cases as you will appreciate, I think, then this is equal to the limit as x approaches a of f prime of x divided by g prime of x. And this is correct as long as this limit, this right side limit exists. So if this exists, we are fine, or it is plus or minus infinity. Alright, and by exists, I mean that it is a finite number. It can be 0 or it can be any other number. And one important note, you can continue this trend. For example, if this limit turns out to be in the form 0 over 0 or infinity over infinity, then you can again take it and use L'Hopital's rule. So you would have double prime of x, g double prime of x like this, divided by, and you would have the limit as x approaches a. So this is fine, you can do it, but I won't confuse the picture here. It is fine, as I said, as long as this is in the indeterminate form of 0 over 0 and infinity over infinity. Now, there are other indeterminate forms. You might have heard some of them. For example, 0 to the power of 0 or infinity minus infinity. These are also indeterminate forms, but you can't use L'Hopital's rule in this case. And to be able to use them, to be able to use the rule on these, you would need to convert them to one of these forms. So you would need to convert them to 0 over 0 or infinity over infinity, and it isn't that hard in most cases. And I will do a few problems on this transformation in my future videos, hopefully. But enough said. I want to give you what the theorem is, because I think it is incredibly powerful and it is very important that you fully grasp the idea of it. So now we are able to start our proof. Let's start with the left side. So we have limit as x approaching a of f of x divided by g of x. And as I said, we will be proving a special case of the L'Hopital's rule. So the special case that we are going to prove requires two things. It requires that f of a is equal to g of a and that these are equal to 0. This is our restraint, basically. This will allow us to make a much simpler proof, because otherwise it is a lot involved than the one that we're about to do. But it is, of course, still doable. So we have this, and I can divide the numerator and the denominator by the same number. This will not change the value of our expression. So I will write the limit one more time, and I want to divide by x minus a. I will divide the top by x minus a and the bottom by x minus a. Alright? And now, at this point, I will make an interesting substitution. I will say, let's make these longer, and I will say I want to subtract f of a from the top and g of a from the bottom. You are asking, how can you do this? This is illegal. You can't change the value. Well, because I can do this, because I didn't change the value. Remember, f of a is 0 and g of a is 0 as well. So it is okay that we can do this. We can subtract or add 0 anywhere we want. It doesn't change the value. And you might notice what this is. Let's focus on this part, for example. What is this? Well, let me write it for you. Let me write it here, perhaps. Limit as x approaches a of f of x minus f of a divided by x of a is defined as the derivative of our function f evaluated at point a. So we simply get f prime of a divided by g prime of a. And we actually get the L'Hopital's rule then. We have completed our derivation. And it is, of course, provided that this part, g prime of a, is not equal to 0. And you can write this in this form, limit as x approaches a of f prime of x divided by g prime of x, so that you can continue using L'Hopital's rule if necessary, because this quotient of the derivatives, well, this might be in the form of 0 over 0 or infinity over infinity. This might be an indeterminate form. In that case, you would need to use L'Hopital's rule again. And what you do is you simply take the second derivative of your functions and look at their quotient. If it is still in the indeterminate form that we are able to use, take it again, and again. And some point, you will arrive at your answer. Anyways, I hope this video was helpful. In the future videos, we will use this rule a lot. So please, if you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care.